I'm starting on whatever pages is of your review. Just go to the second part after the solving. All right, you guys will be given all of the identities, the reciprocal ones, the Pythagorean ones. You'll be given all the sum and difference formulas. That's the sine u plus v, s plus c, however it is, sine times cosine plus, whatever. You will also be given the unit circle. So on your test, there's going to be 11 questions. And the breakdown of them is as follows. There's going to be 4 simplifying, which are like these ones down here. All right, there's going to be 4 solving equation questions, which is what we're going to do in the second part of our review. And then there's going to be 3, I'm going to call them the sum and difference problems. I'm going to show you examples of what I mean by that. Ms. Glick and I talked this morning. We took off the verifying ones, the ones where you do the T-chart and do the proofs on either side. We might add that to a later test to make sure that we cover it, but the test was just too long. Wanted to make sure you guys had enough time and you weren't like super rushed, so I wanted to make sure of that. So the first part I want to talk to you about are these questions right here, which are simplifying. What does it mean to simplify something? Makes it smaller, right? So you guys are going to everybody's going to have a variety of questions. I can't go over every single type, but you can approach every question with the same mindset. The first thing I do is I look and I say, all right, is there anything squared that's attached to a plus or a minus 1? No, so it's not a Pythagorean identity. Do you have anything that's attached with a plus or minus sign? No. All we have here, guys, is division. So now we can say, okay, if it's just division multiplication at the end, or what we have, you're going to convert to sines and cosines. Remember, sine and cosine are your most basic. They're the simplest trig function. So always try to convert to sine and cosines to simplify. So given your identity sheet, some of you can do this without looking at your identity sheet. What is tangent the same as? Sine over cosine. Perfect. So sine x over cosine x. If you're more comfortable with making it theta or alpha or something like that, fine. Change the letter. And then this is over, I'm going to say sine x. I'm just going to put it over 1 because when I have fractions on top of each other, I like to see numerator and denominators. That's just me. So you guys have 2 fractions that you're dividing. How do you divide fractions? You keep, you change, and then you flip. What do you notice happens here, guys? The sign on the top crosses off with the sign on the bottom. So we are left with 1 over cosine x. And I understand I keep telling you that sine and cosine are the 2 most basic trig functions. They are. But you can simplify this a little more because we don't consider fractions simplified. What is 1 over cosine the same as? Secant. So this would be secant x. And there's your answer. You're going to have 4 simplifying. We're going to go through a whole bunch of them here, and then we're going to do some solving stuff, but I want to make sure we cover. Again, you're going to get all the identities that you need on a big sheet of paper sitting right in front of you. So let's go to number 2. All right, what do you notice about number 2? Let's go through the thought process again. Is there anything squared that's attached to a plus or minus 1? No, so it's not a Pythagorean identity. Do you have addition, subtraction signs anywhere in here? No. So there's a couple ways you could do this. Some people want to split this up here. So it's this fraction times secant. You can do that if you want. Remember, if you have a monomial, just one term in the bottom, you can split stuff up. But I'm going to go ahead and just change everything to what? Sine and cosine, because those are the 2 most basic trig functions. It makes life a little easier. So cosine, I'm going to rewrite as a fraction, cosine over 1. What am I going to change secant to? 1 over cosine. And then on the bottom, what's cotangent? Cosine, also Grace, over sine. Good. So before you guys start keep change flipping, what do you notice about the numerator? This cosine in the numerator and this cosine in the denominator cross off. So what are you left with? Just a 1. It's 1 over cosine over sine. So I still have a fraction being divided, so I'm going to keep, change, and then cosine over sine becomes sine over cosine. Now, somebody asked me last period, they're like, can you just leave it like that? Because sine and cosine are the most basic trig functions. Yes, I agree they are, but they're in a fraction form. We don't like fractions. So sine over cosine is the same as tangent. Tomorrow, you guys are going to have to make the decision on, is this simplified enough? You cannot ask me, did I simplify this enough? That's the part of this is simplifying. If you guys got to, say you got to sine cubed times cosine theta. That was, you're like, a different problem. Just say this came up. Is there anything you can do to simplify that anymore? No. This would just be your answer. That's okay. That's okay. It's not always going to be just one plain trig function. It could be a combination of others. But just make sure if you have a fraction, you turn it into a single trig function, something like that. All right, let's scoot along here. Yes, ma'am.
If you would have taken it apart, it would have been like, one of them would have the cotangent under it, and one of them would have one.
Yes, a good question. If you would have taken it apart from the beginning, you could do cosine theta over cotangent theta times secant over 1. Or you could have done cosine over 1 times secant over cotangent. Either way. Good question, though. If you are multiplying and you pull apart, the denominator stays with one piece and the number 1 goes with the other piece. If you're adding or subtracting, you pull apart, the denominator stays with both. All right, so let's go with our same approach that we've been looking at for the last few problems. Is there anything that is squared that's attached to a plus or minus 1? Yes. So then where should our eyes go immediately? To the Pythagorean identities. Is there a Pythagorean identity that has a secant squared and a 1 in it? Yes. Okay, so I'm going to write that one down. It's tangent squared equals, what was it?
1, that's secant squared.
Secant squared minus 1? All right, so is there anything I can do? I just changed it myself, didn't I? Mm-hmm. Let me write the original. What is the original? Tangent squared x plus 1 equals, okay. Sorry, getting ahead of myself. I want to replace secant squared x minus 1 with one single trig function. So here's a Pythagorean identity that has secant squared and it has a 1 in it. How can I rearrange that formula so it says secant squared x minus 1 equals something? I'd have to subtract the 1 from both sides. Do you guys see that? If I subtract the 1 from both sides, what does secant squared x minus 1 equal? So I can replace this with tangent squared x over secant squared x. Now, yes, you could have split this up if you wanted to, gone a different route. That's fine. Just secant squared would have had to be underneath both. It would have been secant squared x over secant squared x minus 1 minus secant squared x. But again, I digress. That would have been fine. So now, guys, yes, we have trig functions squared. That's fine. But there's nothing added or subtracted, attached with a 1 or a plus sign or anything like that. So I go to where? Two most basic trig functions. Sine and cosine. This is sine x over cosine squared x. That's my numerator. What's my denominator? 1 over cosine squared. What do we do when I have a fraction divided by a fraction? You keep, change, and then flip. What do you notice? Your cosines cancel, so you're left with just what? Sine squared x. Perfect. Good. All right, it's going to involve a little thinking, but you guys are going to have all of the tools you need in order to get yourself to the right answer. Sure. Yes, okay, that's good. Say you had tangent to the 6th, and you wanted to convert that. This stays with all of the trig functions you do. Since it's not attached to a plus or minus 1, whatever that exponent is just stays with it. So this would be like sine to the 6th over cosine to the 6th. Yeah, good question. All right, let's look at this last one. You guys are like, oh, I was just kind of getting the hang of it, and then you do this. Okay, first of all, this isn't a verifying one. That's not prove that the left-hand side is the same as the right-hand side. This just says add, right? We're adding two fractions together. When you add two fractions together, what do you have to have first? A common denominator. Perfect. If one of them was a 2 and one of them was a 3, you'd multiply it together and get 6, right? Well, same concept here. I have a cosine theta and I have a 1 minus sine theta, and I'm just multiplying them together. You don't actually have to multiply them, just stick them together and you're telling me that you're multiplying. So now once we have a common denominator, you have to figure out what each fraction has and what the other one needs. So my first fraction, 1 minus sine over cosine, has the cosine in the denominator. What is it missing? The 1 minus sine. So if you multiply the bottom by 1 minus sine, you have to do the top, correct? Okay, fine. The second fraction has the 1 minus sine. What is it missing? The cosine. So what you do to the bottom, you do to the top. Now this is a little different from a lot of the ones that we've done before. A lot of ones we've done before, when you FOIL, the middle terms cancel out. That's not going to happen in this case, but you guys will be fine. Watch. If I FOIL the top here, 1 times 1 is 1. 1 times negative sine is minus sine theta. Negative sine times 1 is minus sine theta. And negative sine times negative sine is plus sine squared theta. Everybody agree? All right, then the next sign I see is a plus sign, so I'm going to write plus. And then what is cosine times cosine? Cosine squared. So you guys are like, wait a second. This looks like a big old mess. Can I just cross off any of the cosines on the top and the bottom? No. All right, everything's attached with plus and minus signs. You can't just cross out yet, but we'll get there. So I'm going to rewrite my denominator, cosine theta, 1 minus sine theta, and then I'm going to clean up the numerator. What do you guys notice? What can we combine? I can combine both of these, right? So it gives me negative 2 sine theta. Is this 1 still out there? Okay. Anybody notice anything else? Does this mean anything to anybody? What does that mean? It equals 1. What is sine? Look at your identities. What does sine squared plus cosine squared equal? Just a plain old 1. All right, good. All right, that looks a lot better. Looks a little cleaner, right? So let's see. Can we clean anything else up? I still have cosine on the bottom here. 1 minus sine. Remember, what's the goal here? We're simplifying. We're making smaller. So what do you notice? What can we combine? The ones. What's 1 plus 1? So I have 2 minus 2 sine theta. Now, guys, we're trying to simplify. That means make smaller. That doesn't look small to me. Can I just cross off the signs? No. We could do what, Marcel? Why can I factor out a 2 in the numerator? Because they both have a 2, don't they? If that said 2 minus 2x, you'd be like, oh, you just take out a 2. Same thing. I'm going to factor out a 2. So when I factor out that 2, 2 divided by 2 is what? 1 minus what? Sine theta over cosine theta, 1 minus sine theta. Well, I'll be darned. What just happened? Now what can I cross off? I can cross off both these 1 minus signs. Good. So I'm left with 2 over cosine theta. Is that as simplified as I can make it? No. Why not? Okay, it's a fraction. Good. See, you guys, some of you are like, well, I don't know why, but it's just not because I can't. So let's just, hypothetically speaking, I had this 1 over cosine theta. What would you tell me that equaled? 1 secant theta, right? So if I have 2 over cosine theta, what do you think that equals? 2 secant. Perfect. If that was a 12 over cosine theta, what would it equal? 12 secant theta. That's it. Good. That's it. That's not the easiest problem in the world. Yep. Sure. Uh-huh. That is not the easiest problem in the world. I understand that. But you guys just don't just stop. Don't just be like, whatever, I can't do it anymore. You can simplify. All of these will simplify. You can make them smaller. You will get partial credit as you go through. If you at least understood here at the top, hey, I need to get a common denominator, all right, that's worth a couple points. If you got to this part and said, oh, look, sine squared plus cosine squared is 1, that's worth some more points. Like each part that you guys show me, we're making progress towards the correct answer, I can give you credit for. So just make sure you're showing. All right, so let's move along. This problem that you guys just took a picture of, right? You're going to have 3 different types of sum and difference. This is 7.2. If you guys want to watch the 7.2 video, the 7.2 practice that I did with you guys, it would probably be helpful. You're going to have 3 different questions that have to do with the sum and difference. One of the questions, and I'm just making this up, so don't take this to the bank like, oh, how come this one doesn't work? I'm just making it up. Say I give you a problem and it says cosine, I don't know, 110. Yes, ma'am. Sure. All right, if I say cosine 110, I guess first of all, let's go back one more step. If you have an ordered pair, right, x and a y, we're dealing with stuff that's on the unit circle. What is the cosine value? X is cosine. What is the sine value? Y. And then what is tangent? Y over x. The reciprocals would be 1 over, or x over y, right? So if you were given this, right, it's going to say, give the exact value. That means no decimals. You guys don't have calculators, but exact value. You're trying to figure out what is the exact value of cosine of 110. Well, if you notice, guys, 110 is not on the unit circle. So this is one of those problems that you have to do what with the angle, bless you, the angle measure that I give you. What do you have to do? You're going to find 2 angles, S and T, U and V, A and B, whoever you want to call it. But you're going to find 2 angles that are on the unit circle that add or subtract to give you the angle measure that I have here. 110 is not going to work. I just pulled something out of my head. But you're going to find those 2 angles, and you get the ordered pair, right? The ordered pair here and here, x and y, x and y. X is your cosine, y is your sine, and then you throw it in the formula that you're going to have. So you might have like, I don't know, square root of 3 over 2 times negative 1/2 plus root 2 over 2 times 1/2. All right, just say that happens like that. What would your answer look like? Well, you'd have negative square root of 3 over, what's 2 times 2? 4. And then I have plus the square root of 2 over 2 times 2 is 4. Would that be your final answer? No, you'd rewrite it over one denominator, and you cannot combine those 2. This is not the answer to this question. I'm just showing you what the format would look like of how you would figure it out. But you guys will be given the formulas. So you just plug in the sine of this one, the cosine of that one, that sort of a thing. All right, the second kind of sum and difference problem you'll have. It'll start off like this. Again, I'm making it up. Sine 15 cosine 30 plus cosine 15 sine 30. All right, are both of those angles on the unit circle? No, 30 is, but 15 is not. So this is going to tell you, hey, write as one single trig function and then tell me the exact answer. So you would look at your formula sheet that you're going to have and figure out what trig function they're talking about. What function goes sine cosine plus cosine sine? S plus t. Good. Sine of S plus t. Good heaven. So this is really the sine of 15 plus 30, which is what? Sine of 45. Is 45 on the unit circle? Yes. So the first part of your answer is there. Then the second part is you would tell me the y value, which is the square root of 2 over 2. Again, 7.2, I did a bunch of these for practice. Watch the video. Yes, ma'am.
Are you going to go to the one where you have one on the homework where it was like sine equals 5 over 15?
Yeah, we're about to do one real quick. Yeah. All right, so those 2 are on the video, and then this is also on the video. This is what Heaven was just referring to. This is not an incredibly hard problem. This is just kind of a long problem. All right, they're not giving you angles on the unit circle. They're telling you, here is an angle, here's one of the trig ratios, figure everything out. This is where you guys have to figure out the x, the y, and the r. All right, you have 2 different angles. They told you theta was one of them, and they told you alpha was the other one. So at the end of the day, you're going to use this formula that they give you. You just got to find out all the stuff you're plugging into the formula. That's the hard part. So in the first theta, they told me that tangent was negative 5/4. All right, that's telling me a lot. First of all, with tangent, what two letters are they giving you? They're giving you y, perfect, and they're giving you x. So with x, y, and r, they're telling you that y is 5 and r is 4. Just kidding. Sorry, x is 4. I don't know why I said that. What do you know? R is always positive. So you don't have to worry about that negative sign going there. But you don't know right now where the negative sign goes. You can figure it out with the two pieces of information they gave you. They told you that tangent was negative. So if tangent is negative, what can I cross off right away? The first and the third. Perfect. All right. So I know it's either in 2 or 4. The second piece of information tells me that theta is in between what two measurements? Where is pi over 2? Up here. And again, you guys will have a unit circle so you can look at pi over 2 and where the other one is. So where are they telling you that the angle is? It's in the second quadrant. Well, what do you know about the x value and what do you know about the y value in the second quadrant? X is negative, y is positive. That is important, guys. That sign is super important. Now, to figure everything else out, this is easy. You say negative 4 squared plus 5 squared equals r squared. So 16 plus 25 equals r squared. 41 equals r squared. Take the square root, right? Now, on your test tomorrow, I did not put any in this type problem that have a square root because you guys don't have calculators. Now, we do all of that work to figure out trig ratios. What is the sine of this angle? 5 over square root of 41. Again, you're not going to have radicals, so don't worry about rationalizing right now. I just want you to get the concept. And then what's the cosine? Negative 4. Okay. Now, the reason that that is important is because you're going to take those values and plug it in where? To that formula, which will be on your paper. You're going to say, okay, the sine is this fraction. The cosine is this fraction. You just plug it in. But I did not put radicals on it to make it that much more difficult. Well, I'll finish it. All right, so now let's go to alpha. What did they tell me about this angle over here? I'm going to have to find x, y, and r. So what did they tell me? Secant. Well, what is secant? Yeah.
Why don't you find sine theta? Oh, no, just asking the cosine.
I'll finish it. What is secant? Reciprocal of what? Cosine. So this is r over x, okay? So they told you that r was what number? 3, and x is what number? 1, okay? So since I know that secant and cosine are positive, what can I cross off? I know that secant and cosine are positive. They told me that it says secant alpha is 3. That means it. So I can cross off t, and I can cross off what? S, good. No, secant goes with cosine, guys. So now with what's left over, they told me this information. The angle lies between 0 and pi over 2. So where is this angle? In quadrant 1. So what do you know about the x and the y value? They're both positive. So now when you find this ends up being the square root of 8. Just x squared plus y squared equals r squared. It equals 8. The square root of 8. Just leave it. We're wasting a lot of time on this problem. All right, so here, the sine, again, if you miss these examples or something like that, you should be watching videos. Like, now is not the time to be like, oh, I wasn't here this day. All right, sine is y over r. So this is the square root of 8 over 3. Cosine is x over r, so it's 1/3. Now, you guys are asking, why? What is the purpose of this? Now that you have these ratios, you now can look at your formula sheet and go, oh, cosine of this plus this, the formula is cosine times cosine minus sine times sine. And you have the trig ratios right here that you just plug in. Cosine of theta is 5 over square root of 41. Cosine of alpha is, I'm sorry, negative 4 over square root of 41. Cosine of alpha is 1/3. And then you minus whatever the other one is. You're just plugging it. Again, this is on the 7.2 video. Right? You will not have these radicals on your test tomorrow. I just made this problem up before you guys came in. That's why it worked out like that. I put a little more thought into the questions for tomorrow. All right, let's go to some solving. And I have some highlighted that I really want to make sure you guys are aware of, that you pay attention to. First of all, when we talk about reciprocal functions, reciprocal, what word do you think of? Flip, okay? Keep that in mind. When you think about reciprocal, think of flip. Now, you guys are going to get a unit circle tomorrow, but I'm not giving you the tangents. If you don't memorize them, that's fine. Just tangent is y over x. Take the y value, put it over the x, and divide. If you memorize them, great. If you don't, no big deal. But let's go through some of these that I've highlighted. All right? What I want to impress upon you enough, guys. You need to isolate the trig function. Don't worry about what it looks like on the outside. Get the trig function by itself. Now you can plainly see what you need to do. What do I need to do first here? Subtract 1. Good. So you have the square root of 2 times sine of x equals negative 1. I want the sine of x by itself. Some people ask period like, oh, so I square both sides? No. Get the square to go away. How do I move it to the other side? Divide by the square root of 2. So sine x equals negative 1 over the square root of 2. What are the sine values? Y. Are there any sine values, y values on the unit circle that are 1 over the square root of 2? No. So what do you need to do with this? You need to rationalize. If you have a radical in the denominator and it's not on there, rationalize. So I have negative root 2 over 2. Now, is there a y value that says negative root 2 over 2?
Yeah,
Where are they?
pi's over 4.
Which, okay, I want negatives. So which ones are they? Where is y negative? 5 pi over 4. Okay. Now, I'm not going to go through all of these and find the angle measures. I'm going to go through to the point to say, okay, sine is y values, find it on the unit circle. This is, when you're solving, this is what your answer should be. You guys should have angle measures on the unit circle. If I can get through all of these and go back and find the angle measures, great. But if not, I'm just going to try. I want to get through the process of solving these. So if you come into something like 35, all right, I want to get cosine squared by itself. So what are the two things I need to do? I need to add 1 to both sides and divide by 4. So this becomes cosine squared x equals 1/4. I want cosine, not cosine squared. Take what? The square root. Guys, when you take the square root of something, what goes in front of your answer? So this equals plus minus, the square root of 1 is 1 over, what's the square root of 4? 2. So you're going to find all the places on the unit circle that have an x value of what? Plus or negative 1/2. So how many answers should you have here? 4. Whatever they are, you should tell me all 4 angles on the unit circle. Yeah. Yeah. All right, your answer should be what? What's one of them? So pi over 3, 2 pi over 3, 5 pi over, no, it should be same denominator. 4 pi over 3?
Yeah.
Okay, and?
5 pi.
Is it 5 pi?
Mm-hmm.
All right. All right, so scoot along. I want tangent by itself, so what do? I subtract the square root of 3. You are not squaring both sides or anything. You just want tangent x equals negative square root of 3. So in this case, if you don't have the tangents memorized, no big deal. You're looking for all the places on the unit circle that when you put the y over the x, you get negative square root of 3. There's 2 places that do that. That should be your answer. Does everybody understand? Okay. So moving on, I just want to make sure we hit all of these. Okay, a problem like this. This is a little different. This one's a little different for a couple reasons. I have one trig function squared, and I have one that's not, right? So it's probably what kind of a problem? Probably a factoring one. So if we are ever factoring, guys, you need everything where? On one side. So I'm going to rewrite this as 2 sine squared x. If I move this cosine over, it becomes minus cosine x. If I move this 2 over, it becomes minus 2. Good. Now, why can't I just go ahead and just factor this? Are the trig functions the same? No. I told you guys the other day when we did this. If you have a factoring problem where one is squared and one is not, one trig function, and they're different, convert to the middle one. Use your Pythagorean identity. Sine squared is the same thing as what? 1 minus cosine squared. Good. You guys will have the identity sheet that already has everything already moved around for you. I gave you the one that's super simplified. So then you just finish the problem here. What do I do with the 2? I distribute it. Great. So 2 minus 2 cosine squared x minus cosine x minus 2 equals 0. Can I combine anything? The 2's cancel, right? So you have negative 2 cosine squared x minus cosine x equals 0. Is there anything in common? They both have a cosine, right? So I'm going to take out a negative cosine. When I divide out negative cosine, guys, what happens here? I'm left with negative divided by negative is a positive. So 2 cosine x, negative divided by negative is a positive. And then what do I do with each piece? So negative cosine x equals 0. 2 cosine x plus 1 equals 0. And you solve. So here, I would look for all the x values that are 0, right? And then over here, I look for all the x values that are negative 1/2. You look on the unit circle, and that is what you would tell me. I'm just saving time here. Where's cosine 0? Where's the x value 0? Pi over 2, 3 pi over 2. And then wherever the x's are negative 1/2. Everybody with? Okay. Scooting along.
Oh, there's going to be a lot with tangents.
There's like 8 different versions. All right, these are the last 3 I want to do. We have time. I changed the one in the middle from the review just because I wanted to give you another look at things. But look, guys, when I see secant, secant is what? What's secant the reciprocal of? What is secant the reciprocal of? Cosine, right? All right, so let's think about flipping. This is a factoring problem. I have 1 squared, 1 to the first power. They're both the same, so that's great. Let's just bring this 2 over here. So this is secant squared theta minus secant theta minus 2 equals 0. What's going to go in the front of each parenthesis here? Secant, good. What are the factors of negative 2 that multiply to give me negative 2, add to give me negative 1? Minus 2 plus 1, right? It's fully factored, so I set each piece equal to 0. All right, this is where sometimes you guys get a little like, oh no, now I have to worry about reciprocals and stuff. What you need to worry about is understanding reciprocal just means to flip. So this is the same as secant theta equals 2, right? And this is secant theta equals negative 1. Now, are there any places on the unit circle where any of the ordered pairs have a 2 in it? No. But that doesn't say find on the unit circle where it's 2. What is secant the reciprocal of? Cosine, right? So if I flip secant, it becomes cosine. If I flip 2, what does it become? 1/2. Now can you find these values? Yes. You look for all the x values where the cosine, the x value, is 1/2. That's the same as saying the secant is 2. Over here, this is cosine, right? And if I flip negative 1, what does that become? Still negative 1. So you're looking for all the x values here that are negative 1. So your answer should be whatever, 7 pi over 3, whatever the equivalent is of the angle. No, Bobby just went. All right, change this problem here to this, please. Change this problem here. I want you guys to see all these different kinds of problems. I have 2 more I want to do, and then we're done. All right, I have a solving problem. I want to get this by itself. It's not squared or anything like that. So I'm just getting that trig function by itself. But cosecant, what is that the reciprocal of? Sine, okay. So we want to get cosecant by itself. So we're going to add 2. You guys agree? Okay, so I have 3 cosecant x equals 2. I still want cosecant by itself, so what do? I divide, oh, actually make this the square root. Just put it there real quick. So you have cosecant x equals 2 over square root of 3. Now before you guys are like, oh gosh, I got to rationalize and all this stuff. Cosecant. What is the reciprocal of cosecant? Sine. I changed the problem. So if I flip cosecant, it becomes sine. If I flip 2 over root 3, it becomes what? The square root of 3 over 2. Before you guys freak out about rationalizing, if it is a reciprocal function, just flip it. So sine is y values. So where are the y values, guys? Positive root 3 over 2. Pi over 3, and where else?
2 pi over 3.
Is it 2 pi over 3? Okay. So there would be your answer. Your answer is always going to be in radians, whatever the angle measure is on the unit circle in radians. You guys are doing great. We're almost done. All right, last one. And I want everyone to see these problems so you can see, yeah. No, sine is y. Cosine's x. No, you need to know that. We've been talking about that. All right, look, I have 2 trig functions. They're not on the same side, but they're not squared or anything like that. This is not a factoring problem. They're not squared. If I gave you guys this problem, 5x plus 2 equals x, what would you tell me to do? You get x's on one side, numbers on the other, right? This is the exact same thing. Get your trig functions on one side, numbers on the other. If it was squared, that'd be different. It would be a fact. If this was squared here, then it'd be a factoring problem. Move it all to one side, whatever. But it's not. Think algebraically. I'm going to subtract sine from both sides, and I'm going to subtract the 2. We'll do it at the same time. So I have 5 sine x minus sine x equals negative 2. What is 5 of something minus 1 of something? 4 of somethings, right? So 4 sine x equals negative 2. You guys are trying to get your trig function by itself. What do? Divide both sides by 4. So you have the sine of x equals what? Negative 1/2. So you're going to go to your unit circle and find all the values where y is negative 1/2. Where is that? You guys look right now. Where is y negative 1/2? 11 pi over 6. And where else? 7 pi over 6. Okay. Good. Remember, if you take the square root, what goes in front of your answer? Plus or minus. That means you won't have just 2 answers. You'll have how many? 4. Okay. Just pay attention to stuff like that. All right, I will post this video. I'm going to upload it right now so it's there for you guys. Say it again. All right, any questions you have? Miss Glick says she'd be here in the morning, 7:45-ish if you want to come and ask questions. I'll be here probably around 7:50 after I walk my girls over, but you're welcome to ask me as well.